All right, we are beginning 3.1 to 3.2 today, and this chapter is all about inequalities. So maybe somewhere, make sure you write these down somewhere in the margin. These are our inequality symbols and what they mean. So we always read left to right as if you're reading a sentence, okay? So something is greater than something else. This one we would read as less than. This one with the line underneath, it's a greater than symbol or equal to. And last but not least, we have a less than or equal to. Okay, so when the line is underneath, we know it's or equal to. Okay, and that's easy to remember because think about it. Really, it's just an equal sign. We just swapped out, it's an equal sign. We just swapped out our top line for one of my inequalities. Okay. All right, so let's just try writing it here. So it says A is less than 4. So we're just going to set it up the same way we read it. So A is less than, so I know I'm going to use this symbol, 4. Okay. Our next one, we have C is greater than or equal to, so greater than or equal to -2. Okay. Now, when we have a solution of an inequality, it's any number that makes the inequality true. So we could have multiple numbers. We could have multiple solutions that make a statement true. So let's just test this one. Here I give you an inequality. We call it an inequality because I don't have an equal sign. I have a greater than symbol right here. Okay, and it says, is the given number a solution of 2x plus 1 is greater than -3? Okay, to solve this, what we're going to do is we're going to take our -3 and we're going to plug it in for x. So I have 2. I replace the x with my -3, so my x goes away. Plus 1. Is greater than -3. Okay? Now we would simplify. So I'm going to do 2 times -3 and get a -6. Plus 1 is greater than -3. We add on this side. I have -5 is greater than -3. Now we look at our statement. 5 is greater than -3. Is that true? Well, if we think about a number line. Here's -3. We go backwards, -4, -5. So -3 is actually bigger. So this is false. So this is not a solution. Okay. Let's try B. Okay, so same thing. We're going to take our -1. We're going to plug it in for our x. So I have 2 times -1 plus 1 is greater than -3. Going to multiply, so I get -2 plus 1 is greater than -3. Now let's solve. I have -2 plus 1 gives me a -1 is greater than -3. This one is true. So this is a solution. All right, I want you to try number 4. So try this one. Try A and B. All right, for A, we should have plugged in our 2. So we plug in a 2. Plug in everything else. Now let's solve. So I have -3 times 2 gives me a -6. Plus 4 is less than or equal to 20. Now I'm going to do -6 plus 4 and get a -2. Is less than or equal to 20. Well, let's see if that's true. Is -2 less than or equal to 20? Yes, this is true, so this is a solution. All right, let's go over here to B. So B, I plug in my -10 for my x. Bring the rest of my problem down. Okay, notice everything matches except for my x. It's all the same. I just took my -10 and I replaced it, okay, in for x. Now I'm going to simplify. So -3 times -10 is 30. plus 4 is less than or equal to 20. Then we get 34 is less than or equal to 20. That is not true, so this is not a solution. Great. All right, let's talk a little bit more about graphing it. So if you look here, we graph inequalities on number lines. Okay, so here we have a problem where we have n is less than 1. Okay, so 1 is my critical point. That's like the moment where something starts happening. Okay, and that comes from this number in my inequality. So that's my critical point, and I notice that n is less than 1. So where are my numbers less than 1? Well, this way, which is why it's darker over here. We shade in that direction. Okay, another little trick you can use with these is you can notice where, if you think of this like an arrow, it's pointing that way. Okay, so it tells me to shade that direction. Okay, now we have to be careful with that, and we'll see an example here eventually. All right, look at our next one. Here, on my second one, I notice my critical point is 0. Okay, so I put a point at 0, and now it says A is greater than or equal to, so I'm going this direction. I'm shading where my numbers are getting bigger, okay? Because where is A? These are all the solution options for A, everything in this direction. Now, notice the difference between my first dot and my second dot. Okay, and our open circle shows us that a number is not included in our solutions. Okay, so an open circle shows the number is not a solution. Maybe you think of it like a loophole, right? Like here's my scenario, but there's a loophole, right? We said n is less than 1. Notice there's no line underneath, so n is not equal to 1. It's just less than 1. So it can come as close as it wants to 1, but it cannot hit 1. That's why we use that open circle on 1, okay? Now the bottom one, it does include my or equals to, which is why I have a filled in circle there, okay? The closed circle shows that a number is a solution, okay? So we're going to use an open circle for my less than or greater to symbols, and we're going to use a closed circle for my less than or equal to or my greater than or equal to. Okay. All right, so let's just look up here. Let's graph these 4 inequalities. So I'm just going to start with my number line, and I always want to graph my critical point. Okay, so I'm just graphing this moment where things are changing, right? So I have my -4, and now mathematicians never just leave one number floating out there. So let's get 2 more at least. Okay, you could do more than that, but I'm fine with 2, 1 on each side. Okay, from here we're going to shade. So it says J is greater than -4. So where, first of all, what kind of a circle am I going to have on here? Well, it's just a greater than. There's no or equals to, so I know it's going to be an open circle. And J is greater than. So where is J getting bigger? It's getting bigger over here. Okay, so I shade in that direction. All right, let's look at number 6. Now, number 6 can be tricky because it looks backwards almost. Okay, there's a couple ways you could do this. I recommend flipping it. So I always like to put my variable first. Now, when I put my variable first, I need to make sure that my symbol is still opening or pointing to the same term. So here, my arrow is pointing to K. Okay, notice that. My symbol is pointing towards K. That cannot change when I rewrite this. So I'm going to have to flip my sign so that I'm still pointing to K. Okay, now I'm ready to graph. So here's my line. Here's my critical point. I have a 4 and a 6. Okay, I look at my symbol. I notice an or equals to, so I have a closed dot. And its K is less than 5, so I'm going to shade to the left. Okay. All right, let's look at 7. Now, 7 and 8 are opposite. They're giving you the graph, and you have to write the inequality. Excuse me. All right. Now, here we have my critical point is -1. So let's start there. And we have any letter. You can pick. I'll pick an X. Okay. Now what I'm going to do is I'm going to notice, first of all, where am I shading? Well, I'm shading in this direction where my numbers are getting higher. So I know that X has to be greater than, because it's getting bigger. Now I look here, I have an open circle, which tells me I should have no line underneath. Look at number 8. My critical point is 0. Let's pick a new letter. I'll pick M this time. Notice where I'm shading. I'm shading where it's getting lower, or where M is less. Plus, I have a filled in circle, so I know it's or equals to. Okay. Now, let's write our inequality to describe our following situations. Okay, so here at number 9, it says the cost of a trail ride starts at $19.99. So, boom, there's my critical number. Let's start there. $19.99. Let's make C our cost, right? That's what we're changing. So the cost of a trail ride starts at $19.99. Now to solve these, what I like to do is ask myself some questions. So I'll be like, okay, if the cost starts at $19.99, could it be $18? Could it be a cost less than this? Well, no, because it starts at $19.99. However, if I think about, okay, could it be $20? And the answer is yes, right? They could charge more. So in other words, my cost could be higher than $19.99. Okay, now we have to take one more question. Could my cost be exactly $19.99? Yeah, it could. If it starts at that price, maybe that's the cheapest price they offer, but they still offer it to people. So we need to put the line underneath. Okay? All right, let's look at 10. It says the legal speed limit in a parking lot is 15 miles per hour. There's my critical number. Our legal speed limit, let's use maybe an S for speed limit. In the school parking lot is 15 miles per hour. Okay, now if it's a speed limit, ask yourself, can I go slower than that speed? Yeah, I could. I could go 10 miles per hour and not get a ticket. Could I go 20? Nope, you would be speeding. So my speed needs to be less than that 15 speed limit. Could I go exactly 15? Absolutely. So it has an or equals to. Okay? All right, equivalent inequalities are inequalities that have the same solution. Okay? So when we look here, let's look at these problems down here. We might see that scenario come into play here. Okay, so basically what this means is this side, okay, is greater than -12. So x minus 15 is greater than -12. Now the nice part here is we're not going to solve any differently. Okay, so I like to draw my line down the middle, even though it's not an equal sign. And I'm trying to get x by itself. Okay, so you guys know what to do. We're going to add 15. So I add 15 to both sides. I get x, and I get -12 plus 15 gives me a 3. Now, we're not bringing down an equal sign. We're bringing down a greater than sign. Okay? So I have x is greater than 3. Okay? Now look at my directions. This says graph your solutions. So let's graph it. Here I have my critical number. Let's do one number on each side. It's a greater than symbol, so I have an open circle. And it's greater than, so I'm going to be shading in this direction. Okay, in the bigger direction. Okay, let's do number, try number 12. Try number 12. Okay, so I draw my line down. I'm trying to get t by itself, so I'm going to subtract 6 from both sides. So I have t is greater than -10. I'm going to graph it. My critical number is -10. Go 1 on each side. Now I see it's an open circle on 10, and t is greater So I'm going to be getting bigger. All right, let's try number 13. Okay, so I draw my line down. Okay, and let's get our x by itself. So I'm going to add 3 to both sides. So I have 13 is greater than or equal to x. Now we're going to graph. So I'm going to flip it, making sure that my symbol is pointing to the same thing again. So this time it's pointing to the x. So it needs to continue pointing to the x as I rewrite it. And now we're going to use this one to graph. So I start with 13. I go down to 12, up to 14. I have a closed circle on 13 because it has my line underneath. And now it says x is less than 13, so I'm going to be shading down, or where it's less than. Okay? Go ahead, try 14. 14 and 15. Yeah, try 14 and 15. All right, 14, draw my line. I should subtract 12 first. So I have negative 13 is greater than or equal to y. However, I need to flip. So I'm going to do y is less than or equal to negative 13. Graph my critical point. I'm going to graph one number on each side. I notice that I have the line underneath, so it's going to be a closed circle. And it's less than, so I'm shading to the left. Ooh. Okay. All right, 15. Here's my line. I'm adding 11 to both sides. So I have m is greater than or equal to 9. Ready to graph? So I plot my critical point at 9. I graph a number on either side. I notice that I should have a filled in dot because of my line underneath. And m is greater than, so I'm going to shade in the positive direction. All right, this will be our last one. So it's a word problem, and it's not much different than what we've seen before, you'll notice. There's one slight change. Okay, so it says the hard drive on your computer has a capacity of 120 gigabytes. You have used 85 gigabytes. You want to save some home videos on your hard drive. What are the possible sizes of the home video collections you can save? Okay, so it's kind of helping me here. So I'm thinking about, all right, what do I currently have to work with, right? How big are the videos that I'm going to be taking? And then how much capacity do I have to work with? Okay, so currently, how much do I have on my hard drive? Well, currently it says I have used 85 gigabytes. Okay, it says you have used this. So 85 would be my current hard drive usage. Okay, now how much capacity do I have? Like, what's my limit? 120. So let's put that over here. So 120 is how much storage I have. I've used 85. Now, if I take some more videos, okay, here's V for videos. I don't know what that number's going to be yet. I don't know how much room I have. But I'm going to have to take what I already have plus the new videos. And let's think about how this is going to be related to my 120. Okay, 120 is my capacity. Can you surpass your capacity, right? So in other words, can you get more than what your phone can hold? No. Okay, it's a limit, right? You can only get 120 is the max gigabytes. So this side over here, the videos we take, and this is our capacity. The videos we take has to be less than or equal to 120. We could hit 120 exactly, for sure. Or we could go less than it, but we cannot go above it. Okay, so that's how we set that one up. Now let's just finish solving it, and then we'll be done. Okay, so to solve it, I draw my line down. I'm going to subtract 85 from both sides. So I have V is less than or equal to 35 gigabytes. Okay, so basically the videos you can collect 35 gigabytes of video. Okay, that's our